Hi, everyone. Welcome to the Firebase recipe to bootstrap your app sessions. My name is Kang, and this is Arun. We are both developer advocates at Google. So before we start, let's get to know each other a little bit. So in our crowd today, please raise your hand if this is your first time attending Google I/O. Wow, that's amazing. It's like almost, 80% of our attendees today. So thank you for raising your hand. Actually, this is also the first time I and Arun we present at a Google I/O session. We are very excited about that, and I hope that you have enjoyed your I/O so far. Thank you. So Firebase. We had more than 20 Firebase sessions at I/O this year, so I believe that you have heard a thing or two about it. We launched Firebase as a unified mobile platform at I/O last year with the goal to have you quickly develop high-quality apps and grow your business. Firebase provides you many ready-made solutions to address common use cases that almost every app developer needs. However, with the increasing complexity of model apps, the offerings that we have in Firebase is also very broad. So I guess that maybe some of you may get confused on where to start when you start using Firebase. This is why we come up with this session to guide you through some of the popular use cases that many app developers implement when they start using Firebase. Today, we'll look at a hypothetical e-commerce app and see how we can quickly add new features to it using Firebase. We'll show 4 Firebase recipes to implement use cases that are quite common when you use Firebase. The first recipe is how to link your existing users into Firebase so that you can make use of all the features that we have in Firebase. The second one is maintaining data consistency in real-time database without duplicating code in clients. The third one is how to send push notification without spinning up your own server. And the last one is how to use re-engagement push notification to improve purchase conversion in your app. And Arun, can you show us the first recipe we have today?
Sure, Khan. Hello, everybody. Let's now see how to link your existing users to Firebase. But first of all, why does linking matter? Linking your existing users to Firebase enables secure access to the real-time database from your client apps. The real-time database is used in our e-commerce app to add an in-app chat feature that allows users to chat with an operator for either price bargaining or just to clarify product specifications. But first, why use the Firebase real-time database at all? With real-time database, you can listen in real time to changes in your cloud database on your client admin SDKs, iOS, Android, and the web. And the SDK also helps you with offline handling. OK, now that we have real-time sync, how can we control access to the Firebase so that a user sees his or her own messages and nobody else's? Real-time database uses security rules to enforce access. In order to allow users to read or write only their own data, you may define a rule as shown here. OK. So now that we know how to implement secure access to the real-time database, back to the recipe. We have an existing e-commerce app with its own authentication backend and user model. So the question is, how do you integrate that user model into Firebase so that Firebase can identify your users and give them access to their data inside the real-time database? The answer is using Firebase Auth. Real-time database uses Firebase authentication for user authentication. When a user signs into your server, a JSON web token is generated, and that's how you certify your user identity. And then when the signed-in user accesses the real-time database, the token is then used to prove the identity and sign into Firebase. Here are the detailed steps to link your existing users to Firebase. First, Sign in your user via your existing mechanisms as usual to your app. Now that you know who your current user is, the next step is to issue a Firebase custom auth token in your server to represent the current user. And finally, use the token to sign in the user to Firebase using Firebase client SDKs. So assuming that you've already signed in the user via your existing auth, here is how you issue a custom auth token for that user. In your server, start by initializing the Firebase admin SDK. Then use it to issue a custom auth token. You only need to specify a user ID from your own auth system, and Firebase admin SDK will do the rest under the hood for you, for example, encoding your token. Once you have issued a custom auth token, just return your token to the app client. OK, so now you have custom auth token in your app. Let's see some code to use the token to sign in your user to Firebase. You need to provide your custom auth token as a parameter for the Firebase admin SDK auth method call. And that's it. You're done. You can now go build your awesome real-time features on real-time database. Pretty simple, isn't it, Khan?
Yeah, I agree. Thanks, Arun. So there's already many high-quality tutorials online on how to implement a chat app with Firebase real-time database. So we won't cover the details of reading and writing from real-time database in our session today. You can check out our Firebase Code Lab to get started. OK, and now you have implemented a shiny brand new in-app chat features on top of real-time database. Let's move to our second recipe for today, how to write your business code accessing Firebase real-time database without duplicating them in multiple client apps. But wait a minute. Why do we need to duplicate business logic? So let's take a look at an example use case. So you added in-app chat features to your e-commerce app. You allow your users to create conversations and invite other users to participate in those conversations. Then you may have a data structure like this. You have a conversations node and a users node at top level. Under each conversation child node, you have an users node containing a list of users who are participating in the particular conversation. And at the same time, under each user child node, you have a conversations node containing a list of conversations that the particular users is participating in. Whenever you add a new person to a conversation, you need to make changes to both conversations users and users conversations nodes, and make sure that the data under those nodes stay consistent. Here is how you implement it for the iOS app. Very straightforward, isn't it? Oh, and you have an Android app as well. So let's write the same logic for the Android app. It's just very similar to the iOS app. But wait, are we writing the same business logic once again? And because you also have a web app, then you ended up duplicating the same business logic, indeed one more time. So one logic, duplicated in 3 clients. Imagine when your app grows and you have a more complicated business logic. Maintaining the same logic implementation across multiple platforms may increase the risk of having a bug that may destroy your database consistency. But the good news is we have Cloud Functions for Firebase, a product that was released recently to help you in such situation. Cloud Functions allows you to run server-side code in a managed environment that you don't need to spin up and run your own server. You can write your logic once using Cloud Functions, and then have your apps trigger the function rather than implementing the logic in each client app. OK, let's see how we implement it. We start by defining our logic. What our logic does is to add a user to an existing conversation. So we name it add user to conversation. It takes two input parameters, the user ID of a user we want to add, and the conversation ID of the conversation we want to add our user to. The output of our logic is very simple. It is just the status of if our users has been successfully added to the conversation or not. And next, let's look into how we implement our logic. First, from our app, we write our logic input in RealTime Database. And then it will trigger a cloud function, which is where the actual business logic is implemented. And lastly, again from our app, we listen to our logic output in RealTime Database. OK, let's look into the first step, writing logic input into RealTime Database. Here's how we represent a business logic execution in our database. We have a dedicated location inside our database under Add User to Conversation nodes to represent each logic execution. Under each child node, we have an input child node, which contains the input of our business logic. In this case, it has conversation ID and user ID of the users that we want to add. Then we have an output child node, which represents the output of our business logic that we want to share with our client app. Here we only have a status of if our business logic execution has been successful or not. Our client app starts a logic execution by pushing a new client node under Add User to Conversation. We add conversation ID of the target conversation and user ID of the users that we want to add to the input object. And then we write it to the RealTime Database. And next, let's implement our business logic using cloud functions. We define our function so that it will be triggered every time our client app writes a new logic input to RealTime Database. In our function, firstly, we extract our logic input from the database. Cloud functions automatically store our input data into the trigger event object, so you can use it right away without explicitly accessing the database. Then we implement the core part of our business logic, updating users' conversations and conversations users accordingly. Please be noted that I'm using an atomic update. So all updates in an atomic update will succeed or fail altogether. So either users' conversation and conversation users both get updated. Or if it fails, then none of the nodes change. Then finally, once our database update has completed, we write the result to the corresponding output node so that our client app can show the result to our user. And lastly, again from our client app, we listen to our logic output in RealTime Database. This is very straightforward. So we had our database reference to our logic execution earlier. So all we have to do is to listen to change in each child node containing the logic output. Once we have the output, we show it to our users accordingly. OK. Now we have all the implementation ready. Let's do a quick demo. Could you flip to the demo machine? OK. So we have our e-commerce app, and we have an in-app chat features that we implemented. Now we have a conversation with two users, Kanako and Mark, in our conversation. We'll go ahead and add another user there. Let's say we go and add Tom to our conversation. So we will expect that after our logic execution, we'll have Tom added to conversations users so that our conversation will have Tom under the list of users who are participating in that conversation. And at the same time, under users conversation, we expect to have Tom added here and have our conversation under the list of conversations that Tom is participating in. OK, let's go ahead and do it. Now you can see that our logic execution has finished, and our client app has added a request to add Tom to our conversation. And the output of our logic execution indicates that our logic execution has succeeded. So as a result, we have Tom here in conversations users. And under users conversations, we have our conversation under the list of conversations that Tom is participating in. And that's it. Let's get back to the presentation. And with this setup, our add users conversation logic even works when the device goes offline. The logic execution will be pushed to the server once the internet connection is restored without you writing extra code to store it locally by yourself. You can even do more complicated logic with your function. For example, you can go one more step, checking if the requesting user is indeed participating in the target conversation before allowing him or her to add other users there. Let's go back to our function and see how we add the permission check. What you do is first check conversations users to see if the current user is participating in the target conversation. If they are not, then do nothing and mark the logic execution as failed. But if they are, then go ahead and update the database, just like what we did earlier. You can do the permission check using security as well, using security rules as well. But doing the permission check inside a cloud function has a benefit of centralizing your database manipulation code in one place, and then you can completely disallow your client to write to the database. And that has concluded our second recipe on how to avoid duplicating business logic implementation by implementing them in cloud functions. Now, let's move to our third recipe for today, how to send push notification by Firebase Cloud Messaging without creating your own server. Let's go back to the chat feature that we built earlier with Firebase. When there is a new chat message sent to a conversation, we want to send push notification to all users participating in the conversation and let them know that there's a new message. We want to use Firebase Cloud Messaging, or FCM, to send our push notification. Firebase Cloud Messaging, or FCM, is another widely used Firebase product. One of the reasons for its popularity is that FCM provides you with an unified API to send push notification to all of your users, no matter that they are on iOS, Android, or web browser. You only need to keep track of your user device instant ID token that you can get from Firebase SDK. Then when you need to send a push notification, provide FCM with the token and the data payload representing your notification content, and FCM will do the rest for you. For example, if the target user is on iOS, then FCM will talk with Apple Push Notification Service or APN to get your message delivered to your end user's device. When you send push notification, you need to authenticate with FCM using your secret server key. So you can't do it directly from your client app, because that will leak out your secret key. You may think that you need to spin up a server just to send push notification, but it's no longer the case because Cloud Functions can do it for you. Let's see how we do it. So there are 3 steps. First, let's write a Cloud Function which listens to a new chat message added to our real-time database. Next, from the message content, compose and send out push notification via FCM. And last, make sure to subscribe our client app to the right FCM topic so that the user can receive the message we intended to send them. We'll go into details later, so don't worry if you don't know what a FCM topic is at this moment. Now let's start with writing our function. Assume that we have our chat message stored under a message node for each conversation. We'll write our function to be triggered when there's a new message added. We have our function to listen to changes in message node under each conversation's node. Once there's change, which means that we have a new message added, we'll send our push notification to all the users who are participating in that conversation. Now let's see how we send push notification. First, we'll take the message content, author name, and conversation ID from the trigger event so that we can use it later to craft our push notification message. Then from the author name and message content, we create a FCM payload to represent our push notification message that we want to send to our users. Next, we want to send our message to our users. Here I make use of the FCM feature called topic messaging to simplify our implementation. What we do is we define a topic for each conversation. We name our topic using our conversation ID because it's easy. And then all you need to do is to tell FCM through our admin's SDK to send the payload to the dedicated topic. Here you no longer have to bother about handling FCM token by yourself because FCM already have it done under the hood for you. And lastly, let's make sure that our users is subscribing to the right FCM topic. So when your users join a conversation, you need to subscribe them to the FCM topic corresponding to that conversation. And don't forget to unsubscribe them when they leave the conversation so that we won't spam them with the messages that they don't care about. And now you have your third recipe on how to send push notification using FCM without spinning up your own server. And it's time for me to hand the stage back to Arun so that he can show you the last recipe that we have for you today.
Thanks again, Khan. So far we have seen recipes that help you build and release your app. Let's now see how we can improve conversions in your app using Firebase. Specifically, we are interested in re-engaging users that add to the cart but abandon the purchase flow without making a purchase. By sending them a push notification, gently nudging them to complete the purchase flow. Here are the steps we'll take to track and reach out to the non-purchasers. First, we track when a user adds an item to the shopping cart. Next, we listen to this event and write details to the real-time database. We'll see what those details are. And when the items in the cart are eventually purchased, we listen to the purchase event as well and remove the purchased items from the real-time database. Periodically, a cron job runs and gathers the list of non-purchasers and their items. And a push notification is sent to all the non-purchasers, nudging them to complete the purchase, thus hopefully helping with our purchase conversions. We used Google Analytics for Firebase to track and mark the user action as conversion event. Cloud Functions, both as a trigger based on analytics events as well as timer based, that we'll see in a minute. The real-time database to store our cart items temporarily. And finally, FCM to send out the push notifications. Let's see each of these steps in greater detail. When an item is added to a cart, an analytics event is logged. Here is some Android code that shows an example of the add to cart event. Notice that the item details are added as event parameters. So we know that Cloud Functions can listen to and trigger based on analytics conversion events. So in order for that to happen, the add to cart event also needs to be marked as a conversion event on the console in order for the Cloud Function to get triggered based on this event. We then define a function that will be invoked when the add to cart conversion event is logged, and this function writes the user ID to the real-time database. If you recall a few slides back, we had logged the item details as the event parameters in our Android code. And these parameters are accessible to the function here, and these are written to the real-time database as well. Here is a snapshot of the real-time database when a single item has been added for a user, when the user adds the item to the cart. As more items are added to the cart, these are also added to the real-time database. The real-time database acts as a placeholder to temporarily hold user's cart data that has not been purchased yet. And when a user makes an actual purchase, the purchase details are logged to analytics and also registered as a conversion event, as we know by now. And when the purchase conversion event is generated, another Cloud Function triggers and removes the temporary records from the real-time database. Here is some functions code to remove the purchased items from the real-time database. And now we have a snapshot of the cleaned up real-time database. All the deleted items are the ones that have already been purchased. Periodically, or at the end of the day, the real-time database now only contains details of non-purchasers and their user IDs and their cart items. But how do we act upon this data really? We'll use functions to read this data from the real-time database in order to send push notifications to these users. But then again, what triggers this Cloud Function? As we mentioned earlier, Cloud Functions are not only triggered by events, but are also run based on time intervals. We use functions cron to trigger our Cloud Functions. Functions cron is really not a feature of Cloud Functions. It's powered by a Google App Engine cron job, which periodically posts a message to Google Cloud PubSub, which then triggers our Cloud Functions. The GitHub repository here shows the source code for the functions cron, and all you need to do is download and run it. The schedule to trigger your Cloud Function can be customized in the YAML file as shown here, so you can do it for your own app. And when the function cron posts a message to Google Cloud PubSub, the Cloud Function is triggered and sends a push notification to the end user, to the non-purchasers, really. And Khan already covered how to send push notifications in the previous recipe, so we're not going to go over it again. So the non-purchasers now see your re-engagement push notifications and may come back and finish their purchase. So now you know how to improve purchase conversions using Firebase. And that concludes the recipes for today. To recap, we saw how to link your existing app users into Firebase using custom auth token. Avoid duplicating business logic by writing business logic inside of Cloud Functions. Send push notifications without a server using cloud messaging inside of Cloud Functions. And finally, try and improve purchase conversions by tracking non-purchasers via analytics and actively reaching out and re-engaging with them via FCM. We have shown you how to use Firebase to build an in-app chat feature within an e-commerce app. However, developers have used Firebase for many other creative use cases. And let's see a few examples. The Wall Street Journal uses Firebase Real-Time Database to cover their live coverage event on their website, wsj.com. Some of the events they have covered includes the US and French presidential elections, sporting events such as the Olympics and the Super Bowl, and also the Oscar award ceremonies. Instacart delivers groceries from local stores to your doorstep. And real-time database enables their sharing cart use case, where users can collaborate real-time to purchase groceries. Hello World, no pun intended, is a Hungary-based travel and discovery app. They're a small startup. They use multiple Firebase features, including cloud storage, to store high-quality images and the real-time database as their main database backend. They chose the real-time database for its ease of use and flexibility. Being a startup, it allowed them faster prototyping and experimentation. And Smart Technology is a South Africa-based company that does classroom education, coordination, and collaboration across both platforms, web and mobile. They implement failover, redundancy, and seamless recovery using multiple Firebase database instances. Standby is a job portal in Japan that connects employers with job seekers. They use real-time database to power their in-app chat feature, much like what we showed earlier today, allowing job seekers to directly chat with potential employers. They also use Firebase cloud messaging to send out push notifications, and they found that it resulted in doubling their conversion rate. Taps Games is a game studio based in Brazil. They use the real-time database and cloud functions to sync game states in multiplayer games. That brings us to the end of our presentation today. For the next steps, please see the Firebase documentation here. You can also keep in touch with us on Stack Overflow and all the other discussion forums you've got. I hope you enjoyed our session and Google I/O. Thank you very much for being here.
Thank you very much.